So last day we stopped here. We are discussing the same data set. We are using that and running several regressions. So last day we stopped with this particular form where, the dependent variable was the health related information, nutrition related information regarding the children of women, and we considered whether the women faced early marriage or not. We considered wealth status. We considered percentage of educated women in areas. We considered the temperature in that area. And if I consider the spatial error model, naturally this lambda will be reported, and we found it is significant at 1% level. So we stopped with this. Today, first, I am going to tell you about the SARMA model. I'll like to estimate the SARMA model. Some of you already did while you tried completing homework, etc., because this is the menu-driven thing, and you will be able to do this thing. However, let's start with this SARMA model. So SARMA model is also known as a combo model because here we will consider the spatial lag as well as the spatial error. So basic framework is Y. That depends on neighborhood Y. The channel is actually, if I consider I is the concerned locality, Yi is affected by Xi as well as Xj. So, nutritional aspect, that depends on proportion of educated women in my locality and proportion of educated women, educated mothers, say, in neighboring locality. So whether there is a culture, whether there is a kind of, awareness, etc., this is coming via mother's education aspect. So since we are doing so, or since we are trying to capture these aspects, Y depends on neighbors Y. Apart from this, there are several X's which we need to consider in concerned locality. Already we are discussing the model several times. So nutrition is depending on whether the mother faced early marriage. Nutrition is depending on wealth, average wealth holding of the families in the localities. So we are considering this kind of variables in X. Now, in this particular combo model, not only we are considering this kind of lag in terms of Y, but also we consider a spatial structure of error. We consider that error has two components. There is some spatial elements. What is that? Whenever we are writing any regression model and bringing one U here, U takes care of the X or several unobservable aspects which we could not explicitly bring in context of or in terms of X. So U is the joint impact of these factors. Now, when we are considering this particular example, explicitly we could not bring women's agency, empowerment. Apart from child marriage, we didn't bring other cultural factors. We didn't bring the language using which the people are speaking. So different aspects are there which we could not bring explicitly in our model. So their joint impact will be there in the error term. Okay, so maybe food habit, cultural links may be a common factor across neighbors. So we are reconstructing the error, keeping those aspects in our mind. So whatever elements we left, we could not bring in the X matrix. Those things are making an interlinkage between concerned locality, and the neighboring locality. So we are writing this U as a function of others U, my neighbors U, plus there will be some random component which we learned as idiocentric error. So that's the idea. Now, if I write U in this format, we can also write it as okay. Is it all right to everybody? I am keeping lambda WU to the left hand side and taking U common. So U into 1 minus lambda W is equal to epsilon, or we can multiply both the sides by 1 minus lambda W inverse, or so this is the format. So U we are presenting as 1 minus lambda W whole inverse into the random component epsilon. So if we present U in that format, our whole equation is becoming Y is equal to rho WY plus X beta. We are replacing U in the first equation by 1 minus lambda W whole inverse into epsilon. Since it is in the matrix format, instead of writing 1, we are writing I. I is basically an identity matrix. So what is happening? This, because of the presence of this W, that is the weight matrix, this lambda W is coming in terms of the matrix. So it is not a scalar. It is a whole matrix. For that matter, we will be not able to present it as 1 minus lambda W. Rather, we have to present it as I minus lambda W, where I is nothing but an identity matrix. Once we write the equation in this form, in the next step, we will estimate the parameters, that is rho, beta, lambda. There are three parameters, three types of parameters here. Rho, which is the component related to spatial lag. Beta, the standard regression coefficients related to the explanatory variables. And lambda, which is taking care of spatial error coefficient. So three types of parameters we are going to estimate, and that also we are going to do using a general method. I wrote about GMM technique, generalized methods of moments. We will do it. Before doing this thing, let's look at the result, what we are getting, etc. Okay, the summary output will look like this. As we run the model, the summary output will look like this, So it is giving information about the data set, about the weight matrix, mentioning the dependent variable, proportion of wasted children, mean of the dependent variable, 16.53, standard deviation, pseudo R square, spatial pseudo R square, number of iteration, number of observations, number of variables, or better to say, number of parameters to be estimated, degrees of freedom. All this general information it is giving. When we are running this thing, we are getting information regarding W underscore P waste. So this is the lagged response for the Y variable. Y is P waste. So W underscore P waste is the neighbor's proportion of wasted children. So we are getting coefficient value and we are getting the Z statistic and we are getting the associated P value. Associated P value is telling us here the lag component is not significant. In this particular example, if you can remember from the very beginning, we are finding lagged information or lagged model is not useful here. Error model is useful. So suggestion was to run the error model. Suggestion was not to run the lag model. Suggestion was not to run the SARMA model. Rather, suggestion was to run the error model. So reflection of that suggestion, we are getting back again and again. We are again finding the year of marriage is important. We are finding wealth holding is important, and we are getting a negative relation between the proportion of children vested and average wealth holding of the area. We are getting, information related to proportion of educated mothers. As the proportion of educated mothers increasing, there is a chance that malnutrition will fall. We are getting information related to temperature. As the temperature in the area increases, in that case, we are finding that, the nutritional aspect may be disturbed. We are also getting information regarding lambda. And if you look at the p-value, this lambda is significant at 1% level. Okay, so lambda is the coefficient related to spatial error. Since the model will be estimated using the two-stage least square technique, we are getting information which variable has been instrumented and what are the instruments. So in our example, in our particular example, the right-hand side Y associated with neighbors, that is endogenous in nature because it will be affected by the remaining factors. There will be some association, as I discussed last time, between these first component and U. The problem of endogeneity mostly comes from the issue the right-hand side, any one or several or all components are related to the error term. So when we are considering this kind of spatial lag, these neighborhood Y related equations actually can be planned using same set of explanatory variables. So similar type of variables which we are not bringing explicitly in the regression model will be there in the error of my neighborhood as well. So for that matter, this rho wy, better to say this wy will be related to u. Wy will be related to u. In this particular equation, we have not explicitly considered women's empowerment. In my neighbor's equation of proportion of children vested, we are also not considering women decision-making power or any factor related to women empowerment. So for that matter, whatever elements are left, that is creating a noise when we are looking at the relation with U. So all these WY will be related with U. And that is bringing the aspect of endogeneity. So OLS is not applicable we have to use some other method. One of the suggested method is 2SLS, two-stage least square technique. So here we are getting result of the two-stage least square technique. Now, instrument is a kind of variable which will be highly related to this WY. However, that will be not related or unrelated to U. So what we are considering the WX variables, weighted X variables here. For example, proportion of educated women in my neighborhoods, not in my place, in my neighborhood, or wealth holding in my neighborhood. So we are considering those things. So all these factors will not directly will be related to the error term in my locality. So when I am considering the error term in my locality, here we will consider the X variables which we could not bring in this regression equation. We are not considering X of the other places. So X of the other places, which is highly related to this WY, because WY means Y of the other places. So Y of the other places will be highly related to X of the other places. However, X of the other places will be not related to U of my locality. So this is the area, this is the idea behind the instrumentation process. So all these weighted C marriage, weighted log wealth holding, weighted education, weighted temperature, these have been used in place of W underscore P waste to estimate the regression model. Basically, W underscore P waste will be regressed on these four factors to begin with, and then we will get one estimated coefficient value. That coefficient value will be plugged in the original model, and then at the second step, we will estimate this particular model. So roughly, this is the 2SLS technique. So we are using the 2SLS technique to estimate the parameters of the model. Okay, so before going further, let's do the things. So would you please open your Geoda space? So we know in the first step, we need to incorporate the data. So Jishnu or some other participants who forgot how to do the things, please check the matter. So after opening Geoda space, we are opening the data file. So child.dbf is the data file. Next, we have to open the weight file. Child.gal is the weight matrix. Okay. Then we need to consider the y and the x variables. Y variable is either p waste or PCIAF. So we are bringing the variable here. And we have to bring the variables in place of x. So we are considering C marriage, temperature, then we considered log wealth and PAB. Dragging all these variables here. So we are getting X variables. So we will like to run this time, this combo model. So we are clicking on the combo model If you want to estimate OLS, click on standard. If you want to estimate spatial lag model, click on the second item. If you want to estimate spatial error model, click on the third. And if you want to estimate the combo model, click on the last one. Okay. And then click on run. You are getting the result like this. The same result, just we interpret it. Everybody could do it.
Yes, ma'am, I could do it this time.
Okay. So this is the way. And already I mentioned something about the interpretation of the result. Okay. Now we will go back to the Anselm's chart. At least we learned one method, GMM. Sometimes we are getting the result related to 2SLS. Sometimes we got the result related to weighted least square. All this formula or all these specifications are coming under the umbrella GMM, generalized method of moments. So at least we learned a technique by which we could run the lag model, error model, and the combo model, which is the spatial lag plus error model. Now, how to select a model, how to finally come to the conclusion, which model you will do. So this is the pathway which we learned, how to select the model, etc. last time. So we said that if we find one of the LM error or LM lag significant, following the channel, we will go for LM error model or we will go for LM lag model. Just hold for a moment. Hello, Manzar. Hello. Okay, so however, last day I mentioned both the LM statistics are diffused. So always it is good if you consider the robust measures. And if both are significant, in that case, you have no way out. You have to look at the robust LM statistic and robust lagged statistic. If we find one of the robust is significant, accordingly, we will select our model. Okay. And if both are significant, in that case, we can move for the SARMA model. Okay. So this is the standard pathway which we discussed. Now the thing is, when we are trying to capture the spatial aspects, our most focus generally will lie on the spatial lag model. Because in terms of network, we want to capture the spatial aspects. If we fail in that case, we go for error model. SARMA is the general kind of context. Actually, we are not getting fully the sense why or how the network is built up, because we are not understanding whether mostly it is coming via the lag channel or it is coming mostly via the error channel. So our first interest will be on the lag model. If we fail, the second interest will be the error model. If no way we are comfortable with the lag and error, naturally we will go for SARMA model. Okay. Now, if you find both the LM error and LM lag, as well as robust LM error and robust LM lag, all the coefficients are significant. Okay. And because of your research work, you don't want to go for SARMA, say, in that case, look at the coefficient values. Look at the coefficient values. You will go for the lag model if the coefficient related to robust LM lag is higher than coefficient related to robust LM error. On the other hand, if robust LM error statistic is greater than robust LM lag statistic, in that case, you can go for error model. You can go for error model. So when it is research related work, you have to apply your mind while you are selecting the model. Blindly, many a times we do not follow the pathway. We follow the pathway, which can give, a different dimension to our research. So although the pathway is like this, and you learned how to estimate first model, second model, and third model, while you are taking decision which model you are going to present, please look at the factors. Please look at the factors from different dimensions and finalize your model specification. Now, 2SLS is a technique by which we can estimate the model. Another possible method of estimation is the maximum likelihood estimation technique. So we will also learn how to estimate the maximum likelihood models as well. We went up to this, we learned up to this. In the next step, we are going to estimate the same tree model applying the method of maximum likelihood estimation technique, following maximum likelihood estimation technique. There is some good aspect related to MLE. MLE does not consider the MLE is based on the distributional aspect. So to apply MLE, you need to have idea about the need to have ideas related to what will be the background distributional structure of your data. So distributional aspect becomes important in context of ML. Therefore, some of the econometricians do not like the maximum likelihood estimation method. However, some of the econometricians like maximum likelihood estimation technique because whatever coefficient estimates you are getting, those estimates are following the large sample property. All the estimates are consistent, efficient. So since you are getting a number of limiting properties, this method is a method which is applicable for the large sample. Therefore, another school like this maximum likelihood estimation very much. So one school does not like it because here you need the distribution, information related to distribution, and another school like it because it has the asymptotic or the limiting properties. Okay, so we will learn both the things. Okay. Any question is there?
Ma'am, may I ask a question?
Okay, let me first take the question.
Yes. Oh, okay.
Uh, lambda is related to the spatial error. It's the coefficient related to the error. So if lambda is insignificant, in that case, you don't have the presence of significant spatial error If lambda is significant, like this case, in that case, you have significant presence of spatial error. So this is the idea, So lambda is related to the spatial error. In fact, in the combo model, we discussed about this lambda. Lambda is associated with the spatial error. So if lambda is significant, that means you have significant spatial error. If rho is significant, rho means W underscore the Y variable. So rho is coming in that way in the software. So if that W underscore Y variable, that means the rho is significant, then there is spatial lag, which is statistically significant. If lambda is significant, that is indicating there is spatial error, which is statistically significant. Vandana, is it all right?
Yes, ma'am. But as you have given the assignment, in that case, actually, the spatial lag and the spatial error both are significant. That's why I have run the Sarma model. But in that case, the lambda is actually insignificant. So that is the confusion. Is it correct or not? That's why I'm thinking about.
Okay. So
Yes, ma'am. I'm having the same problem.
okay. So when you ran the OLS for PCIAF, what was your information? Because you
Ma'am,
were
it's significant, ma'am.
All four coefficients, that is LM error, LM lag, robust LM error, robust LM lag, everything significant?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. And also the lag related to SARMA, that is also significant. Okay.
Yes, ma'am. All are significant except the
All are
lambda.
significant. Okay. Okay. All are significant apart from lambda.
Yes, ma'am.
That is, in the OLS model, your error is not significant. LM error or robust LM error is not significant.
Ma'am,
No,
all
ma'am.
are
All are significant.
Yeah, all are significant. You told all are significant. In that case, either you can run Sarma model, that's all right, or as I mentioned just now, okay, you can check the coefficient value of the robust LM lag and robust LM error.
Ma'am, robust LM error, I think it is greater, 9 point something, and it is 7 point something.
Okay, fine. In that case, Sarma is in your hand. You can go for Sarma. No issue. However, you can also go for robust, since robust LM error coefficient is higher than that of robust LM lag, you can go for error model as well. Okay, so please look at these black, the things which I have mentioned in these black boxes. In some cases, especially when the number of observations is too large, both robust test statistics may still be significant. The preferred alternative would be the one with the highest value for the statistic. Decision rule needs to be applied with caution, since there may not be sufficient evidence to clearly select one alternative over another. So what I said, if both robust LM error and LM lag significant, first of all, LM error, LM lag significant, then both robust LM error, robust LM lag significant, the theory is telling you go for Sarma. All right, you can go for that. Whatever result you are getting, that will be the final result. Another thing is that you look at the coefficient values of robust LM lag and robust LM error. Whichever coefficient value is higher, that may give you direction regarding what can be your preferred model. Okay, because what you are telling, when you selected Sarma and estimated Sarma, you are finding that lag is becoming insignificant. Am I right?
Yes, ma'am. Lambda is becoming insignificant.
Lambda is becoming insignificant. Okay. So, although you followed the theory, however, the basic construct is not, as we expected or as we wanted. So, for that matter, in that particular case, don't go for Sarma directly. Please check the coefficient values of the LM error coefficient and LM lag coefficients. As you are telling, LM error coefficient is higher. So why not you are choosing the error model? So that's the idea. Do something, take your final decision very, very carefully.
Ma'am, can we report both the results, means Sarma as well as with the error model?
Yeah. If it gives different types of insights in terms of other variables, etc. Because your story is not only related to space related matter, there are some other x variables, etc. So apart from weighted y variable, there are issues or your hypothesis related to the coefficients associated with other explanatory variables too. So if uh, putting both the models in your analysis provide different dimensions of the story, in that case, please do so. If they tell the same story, in that case, you can concentrate only on a single model. All right.
Yes. Yes. Thank you.
Okay, so let's now move for ML estimation on the scene. So we are now going to do these things using the maximum likelihood estimation technique. So, please open your Geoda space. Okay, I think I have to close it. Otherwise, it will create a problem. So you can close everything. And would you please reopen Geoda space? Please open your data. Take the weights. Keep the variables aside. Select spatial lag and select ML. Standard here will be not estimated using the ML. So this is the built-up software. As you know, the coefficients related to a standard classical regression model can be estimated using the maximum likelihood estimation technique. Here, we are not getting the option ML with the standard context. Only for spatial lag, spatial error, and combo model, we are getting the option ML open to us. So click on spatial lag, and then please click on ML. You have to select your Y variable and the X variables. P waste we are considering as Y variable, and temp, seabarage, wealth, and education we are considering as X variables. and click on run. You are getting the result. Maximum likelihood spatial lag model. So in the first table, you are getting the information related to overall significance of the model. Carefully check the information. In the 2SLS case, you didn't have the information regarding Akaike information criterion, Swodge information criterion. Here you are getting information about these things. In the earlier case, you got information regarding mean, standard deviation, pseudo R square, spatial pseudo R square, etc. Sigma square in that case was based on least square. Here it will be based on ML. So all these changes you are getting here. Interestingly, here you are getting information regarding goodness of fit in terms of AIC and SC, that is Akaike information criterion and Swodge criterion. The next table is more or less similar. You are getting the coefficient value. Since you have considered the lag model, P waste has been regressed on neighborhoods P waste. So this is W underscore P waste, which is equivalent to rho in our theory. So which is highly significant. Early year of marriage and wealth are becoming insignificant in this model. Education is playing a significant role, and sign is negative, indicating an inverse relationship between education, percentage of educated mother, and the malnutrition of the children. Temperature is significant and has positive impact on nutritional related aspect. Okay, now geoda space is not giving us the third layer of information, that is several information related to regression diagnostics. The same we will estimate using geoda. Geoda will give some more information mainly related to regression diagnostics. This part will be more or less similar in geoda and geoda space. In geoda, we will get some more information. So this is the ML technique. Let's do quickly the error model. Click on spatial error. ML is already there. You have the selected list of variables in your Y and X boxes and click on run finally. So this is the result related to the error model. As I mentioned, the new thing will be there, Akaike information criterion and Swodge criterion, and all the sigma square, when it will be estimated, that will come in terms of A square based on ML technique. In case of least square, while you are using least square, this sigma square or the sample variance of the model will be estimated using the least square estimates. And if you use ML, all this will be estimated by E prime E by N. In the other case, E prime E by N minus K. So there will be a difference between the two. You are getting coefficient values, etc. The spatial aspect is this lambda. Lambda is statistically significant in the ML model. So if we estimate the same information using the ML technique, maximum likelihood estimation technique, we are finding the lag as well as error, that is the lambda, both are becoming significant at 1% level. If you can remember, when we used the 2SLS technique, the lambda was insignificant. However, when we are using the ML technique, that is when we are using the asymptotic properties, we are using the limiting properties, what we are finding that both the lag coefficient in terms of space and the error coefficient in terms of space are becoming statistically significant. So I hope you are understanding you have to play around. You have to check everything. And finally, you have to understand this is my right model and this is my right method of estimation. Okay, in the third go, we are considering the combo model, spatial lag plus error. I think in Geoda space, this combo model cannot be estimated using the ML technique. Okay, this combo model actually cannot be estimated using the maximum likelihood estimation technique. Okay, so spatial lag and spatial error model can be estimated either using GMM techniques or using ML technique. However, spatial combo model cannot be estimated using maximum likelihood estimation technique. Okay, so if it is the spatial combo model, in that case you need to apply 2SLS technique only. So there are several things we have to keep these points in our mind. Okay, so quickly open your Geoda. Okay, and let's run the maximum likelihood models using Geoda. So I'm closing Geoda space. And opening Geoda. So bringing the data here. Select the DBF file. And select the right DBF file. Close it. We are getting Geoda open. Click on Tools, Weight Manager, load the weight. You can close it. Come to regression. Another regression window is opening. Click on that. And then we are getting this box. We have to select our Y and X variables. P waste we are selecting as the dependent variable. And then log wealth, education, temperature, and marriage. These are the 4 variables we are considering. Okay, click on this weight file. Then come to spatial lag. Okay, run the model. So we are getting similar kind of information here, giving overall significance of the model. One extra information is here. Log likelihood information is also here. Akaiki swatch information is like this. Rest of the things are similar to that of Geoda space. Okay. Then we are getting this model. Coefficient values, Z values, probability values, etc. Lag is significant at 1% level of significance because we are using maximum likelihood estimation technique. In case of Geoda space, we found when we are using the ML technique, the lag is becoming significant. The new thing is here. We are getting several diagnostics results. One is the Bruch-Pagan test, which is telling us some information related to heteroscedasticity. We are finding the null hypothesis is homoscedasticity, and that has been accepted. Looking at the probability value, we are understanding that null hypothesis has been accepted. We are also getting information like, likelihood ratio test, which is giving the information whether spatial lag dependence for weighted metrics is significant or not. The null hypothesis, it is insignificant. Looking at the probability value, we are understanding that null hypothesis has been rejected at 1% level of significance. Okay, so this is the additional thing which we are getting from Geoda. Closing it and running spatial error model. Everything is like before, so we don't need to make any change there. Let's run this. Okay, so similar kind of information we are finding. Apart from the regression, we are getting information regarding regression diagnostics as well. Look at this slide. So in the ML models, what are the things which we are getting? What are the things which are different from that of least square based models? One is the measures of the goodness of fit, AICSC criterion. Along with the pseudo R square, you are getting information regarding this. Another is diagnostics related to LR test, likelihood ratio test, which is telling, whether the null hypothesis regarding spatial independence has been rejected or accepted. Spatial randomness is the null hypothesis, whether we are rejecting this or whether we are accepting this. So in our case, we are finding this LR statistic is significant at 1% level. So we are rejecting H0 of spatial randomness. We are also getting information regarding detection of heteroscedasticity because Grush-Pagan-Lagrange multiplier ML estimation is there. So, you will be able to give information whether there is heteroscedasticity, whether there is homoscedasticity, etc., etc. Okay. Any question? Anything you will like to know? Anybody, any question?
Ma'am, regarding the likelihood ratio test, the interpretation will be like, means what is a null hypothesis, ma'am?
Spatial
Likelihood.
spatial randomness. Okay, there is no spatial element in our structure. Spatial randomness is the null hypothesis. Okay, so in the next step, we will go further. What we have to do, if there is endogeneity aspect related to X variables. So far, I discussed about default endogeneity, which is coming via network or spatial interaction. Y is a function of neighbors Y, weighted Y, and that weighted Y is related to error, because all these weighted Y are based on the variables which we could not incorporate in the model. And for that reason, this weighted y is becoming interrelated with u. This is the default endogeneity. However, there can be endogeneity coming via X channel as well. So now we have to disclose that kind of story. And this particular model will not help us to discuss the matter. And for that reason, I sent you a new data set. With the help of that Columbus data set, which I sent you in the Google Classroom, now we are going to discuss along with the spatial aspect, spatial endogeneity, type of model, we need to find out what will be the proper estimation technique if there is endogeneity for some of the explanatory variables as well, X as well. What will happen? So this will be our next step of learning. If you could not download the data, before starting of the class, please download Columbus data because the next part of the analysis will be based on that. So let's have a break for 5 minutes and then we will start doing that particular model building exercise. Okay, before taking the break, is there anybody who joined later? Okay, so let's start from 45. This is 2037. Let's start from 2045. Okay, so to learn something, how to manage the issue of endogeneity in context of X variables, let's once again see what is the context or why.
Ma'am,
Yeah.
ma'am, yesterday you had said that you would explain the interpretation for the Ansel and Kiligian test. So, for that also is the null hypothesis spatial randomness as opposed to spatial dependence.
Yeah, yeah.
Okay.
That is a measure of, the two things are different. The Anselin Kaligian measure, that is based on spatial autocorrelation only, that is based on rho. Okay, and it is forming a statistic which is based on Moran's I. Okay, so it is
Yes, ma'am.
capture the significance of rho, spatial autocorrelation, whereas the likelihood ratio test, that is directly related to the regression coefficients, and it is telling that the regression coefficient rho will not be significant or not be significant or significant. Okay, so they are addressing the same thing, but the conceptual aspect is little bit different.
Okay, ma'am.
Yeah, one is based on the theme of autocorrelation, another is based on regression coefficient. Now happens to be in our analysis both the things are same, rho. Okay, however, if it is not a spatially autocorrelated framework, if it is a standard ordinary least square framework, in that case Anselin Kaligian will check whether the model is suffering from any autocorrelation or not, error related issue. Whereas the LR statistic, that will check whether the beta coefficients are significant or not. Okay, so views are different. Actually, the statistics are checking significant for different matters. In our spatial regression framework, what has happened, both the things are becoming the same rho. If you try to explain it in terms of autocorrelation, your focus will be on rho. If you want to focus it on as a parameter to be estimated, then also your focus is on rho. All right.
All right, ma'am.
Okay, so already I mentioned, the endogeneity is an issue where there will be some kind of association between X and U. So let's try to understand this using an example, nothing related to spatial. It is general example. So we are considering earnings or income as the dependent variable, and suppose that is regressed on years of schooling, X, and there is an error term, a simple two variable regression model. Earnings is a function of years of schooling, and there will be some random error component in the model. So X and U will be there in the right hand side, Y will be there in the left hand side. One of the very important assumptions in this context is expectation of U given X is equal to 0. Expected value of U given X is equal to 0. And that finally results in a consistent set of beta hat. Beta hat will be unbiased in terms of finite sample. It will be consistent in terms of large sample. Now, if we consider a different context, okay, that is, if we start thinking on elements of U, elements on U, that U embodies other factors determining earnings apart from education. Here I have given one example: skill or ability of the respondent. It can be something else as well. Unobserved factor, which explicitly we could not bring in the regression analysis. So people may have similar level of education, but still their performance in interview may differ, because people have different levels of ability. So that unobserved ability, that is actually determining what will be your earnings, but that is not reflected in the set of X. So this element is there in the error term, and this ability may be functionally related to education. So ability and years of schooling are interrelated. Ability is unobserved factor. Via these unobserved component, X and U may be related to each other, resulting in covariance UX not equal to 0. So that's the idea. Now, if covariance between U and X is not 0, as you know, one of the very vital assumptions of the classical model, that will be disturbed and you will be not able to estimate unbiased as well as consistent estimator. The problem is when we are interested in estimating beta hat, we want to estimate the direct impact of years of schooling on earnings. And we will be able to tell, if higher the education, better the earnings, or if you have higher education in this particular channel, you can have higher level of earnings. So this kind of thing we will be able to claim, and policy making will be an easier job. Here the problem is there is a direct effect of X on Y, years of schooling on Y. There is another indirect effect. Ability resulting in better education, resulting in better earnings. So if this indirect effect is there, along with the direct effect, naturally, the standard estimator, beta hat, will be not able to capture the second, and therefore it is incomplete. It is not a perfect measure of interrelation between Y and X. Now, the example we are going to consider, that is an example of crime in a particular locality, whether this crime in a particular locality is affected by crime in the neighboring area. So this is the basic model. So we have a variable crime. This crime is taking care of residential burglary and vehicle theft, property related matter. We are not considering all sorts of crime. We are considering a typical type of crime which is related to property. We have variables like area, which is indicating neighborhood area. What is the breadth of the neighborhood area? INC, which is household income in 1,000. Crime is also measured with, subject to the 1,000 household. So this is the burglary or vehicle theft per 1,000 household. This is the measure. Income is also household income per 1,000 households. HO val is the household value that is also given in thousands. Open is a variable which is indicating area under the open space of the household. Whether there is courtyard or open space, ground, etc., along with that particular house. Plumb is another variable that is indicating percentage of household without plumbing facility. So it is also giving certain indication of household quality. So, residential burglary, we will like to associate with this kind of variables. These will come as our X variables. Now, to make it short, since household value may be related to the percentage of household without plumbing, or, open space, or neighborhood area, okay, we are creating a simple model where we are considering crime will be function of HOVAL, household value in thousand, and income. Okay, so this kind of model we are going to build up. Now, I mentioned we are trying to bring endogeneity not only because of presence of the spatial aspect, crime of my locality depends on crime on other locality. We also want to bring endogeneity for the X variables we are considering. Here, the specified variables in the model is the household valuation and another is income. So now we are interested in bringing endogeneity with respect to one of these variables. Okay. So while we are writing this kind of model, crime is a function of household valuation as well as income of the household income in the locality. When we are bringing this kind of thing, household valuation may depend on in the area where the household exists. Like whether the locality is a locality where we have all multi-storied building, or whether it is a locality, which we call a para type, that kind of locality, or it is a locality surrounded by slums, or it is basically in the slum area. So all these aspects also determine household valuation, which are not there in our model. So this is one aspect. Another aspect is there can be the presence of reverse causality. What is the reverse causality in this case? Higher the HO val, higher is the household valuation, it is indicating better is the locality. That in turn indicates lower will be the percentage of crime. Higher the value of HO val, that may indicate lower the percentage of crime. Or lower the percentage of crime, that in turn indicates HO val is quite good. So there is reverse causality. X is determining Y is also determining X. HO val is determining crime rate, and crime rate is also indicating what can be the HO val. If crime rate is lesser, in that case, HO val will be good. If crime rate is high in a locality, HO val will be poorer. So there is two-way causality which can be there in this particular setup. So there may be unobserved factor which may interrelate X and U. Again, in this particular model, there is the possibility of reverse causality. Higher the rate of crime, naturally lower will be the valuation of the house. Lower the crime rate, higher will be the valuation. On the other hand, as we discussed, higher value of the buildings, that means, it is located in quite a stable surrounding, and crime rate will be naturally low. So all these aspects will help us to consider HO val as one of the endogenous variates considered in the model. So with this idea, now we are going to estimate the regression equation using geoda space. So please open the geoda space. Click on this file, data file, and please bring the columbus.dbf. Columbus.dbf here. Click on the weight file and please bring columbuscrime.gal. So dbf file and gal file. Are the things ready? Yes or no?
Yes, ma'am.
Yes,
Sana?
ma'am.
Yeah. Very good. Now, what is our y variable? Crime. So select crime, bring it in place of y. Okay. Now, what are the x variables? One is HO val and another is income. Income is a variable which is not endogenous in nature. However, if you suspect any variable to be endogenous, you have to bring it under YE. So, HO val that let's bring under YE. We are considering this variable as endogenous explanatory variable. Endogenous explanatory variable. So if there is some endogenous variable, we need instrument for that, because this variable will be regressed on that instrument. We'll get the coefficient, we'll plug it in the original regression equation if we follow the 2SLS technique. If we follow the ML technique, we will consider this as an instrument. Now, what is the instrument? The instrument or instrumental variable will have very high association with the endogenous variable. However, this variable should be independent of the error term. So we need to find out one variable which is highly related with this household valuation. The variable here I am considering is the open space, because higher the open space in with the buildings in a locality, in general, our idea is higher will be the valuation of the buildings. So we are considering open space associated with the buildings, which is highly correlated with the household valuation. However, okay, we are considering that this open space, whether there is a ground or whether there is, swimming pool, this is not affecting the crime rate. Household valuation is affecting the crime rate, However, the open space, that is not directly related to crime, and therefore it is not associated with the error of the equation. It is not directly related to Y. It is not related to the crime rate. You can also use the percentage of plumbing area, because that will be related to the household valuation. However, that will be not directly associated with the Y term. Since here we are also talking about the reverse causality, therefore I am discussing the matter in this way. So instead of HOVAL, if we can bring certain proxy like open, percentage of plumbing area, those things will be highly related to HOVAL and therefore will be good proxy to this variable. However, it will be not directly or indirectly affect the crime rate. So these variables can be used as instruments. So I am doing the thing like that. So I am bringing open in the place of instrument. So here there are 4 boxes. Y or the dependent variable will be there in the Y box. The exogenous X variables will be there in the X box. The endogenous or suspected endogenous X variable will be there in the YE box. And for the endogenous variable, or for that particular endogenous variable, the instrument will be reported in the box of instruments. So once the things are ready, you can run the standard model, or you can estimate the spatial lag, spatial error. Since here our objective is to find out, the spatial lag model, you can start with the spatial lag, or, for the first time, you can derive the standard model using the GMM method, and then you can proceed for the other models. So let's first start with the default structure, standard. Then the default is GMM. It is already selected. OLS is not the right method because with the OLS, we can only find out the direct effect of X on Y. We cannot find out the indirect effect on Y. Therefore, this will be not the right method. So click on Run. You are finding 2SLS has been estimated as standard model. You are getting information regarding the model. Your dependent variable is crime, mean of the dependent variable, standard deviation, pseudo R square, number of observations, number of variables, degrees of freedom, 49 minus 3, everything you are getting. You are getting the coefficient values, Z statistic, probability values. In this particular model, we are finding that if I considered the simple 2SLS structure, no space is here, nothing related to spatial aspect has been captured here. So this is not at all a spatial model, spatial framework as such. So in this model, HOVAL is not determining the crime rate. It is the income that is determining the crime rate. Higher the income in the locality, lower the crime rate. So this is the interpretation of this particular model. You are getting information regarding instrumented variable, HOVAL, instrument open. You are getting some information regarding regression diagnostics. You are getting Anselin-Kalijian test. Okay, that is related to whether there is any autocorrelation in the error term. We are finding the model is not autocorrelated. The model is not autocorrelated. Next, let's try the spatial lag model. Run the model, select spatial lag, then run the model. This is the result. The main difference with the earlier result, here you are getting W underscore crime, and that is significant at 5% level. This is positive. if there is crime in your neighboring locality, the crime in your locality will be higher. So there is spatial lag effect. Okay. So, you are getting some sense of hotspot for the crime. If in the neighboring locality crime rate is high, in that case, in your locality crime rate will be high. Again, you are finding HO val is insignificant. However, income is significant at 5% level of significance. Okay. So spatial lag effect is present. And along with that, income is important to determine crime in a particular locality. Okay. Instrumented variables will be W underscore crime and HO val. W underscore crime is default endogenous variable. Additional endogenous variable is the endogenous X HO val. And your instruments are W underscore income and W underscore open for W underscore crime, following the logic which we discussed earlier. The last variable open is the instrument to HO val. You have information regarding Anselin-Kalijian test. Next, we are going to estimate spatial error model. Select spatial error, keep rest of the things unaltered. Run the model. Look here, every time it has been written HOM. So considering homoscedasticity, we are running this model, spatial error model. Okay. So there is some first set of information indicating overall significance of the model. The second set of information is related to the coefficients. And here you are getting report of lambda. Okay. Spatial error coefficient. However, spatial error coefficient is insignificant here. So for this particular model, actually the lag model is good. When you are running the spatial error model, spatial error coefficient is becoming insignificant. There is negative as well as statistical significant association of income with the crime. Everybody could run it. You are running the models. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Finally, this is the combo model. Spatial lag plus error, GMM. Run it. Here, you are getting report of W underscore crime and lambda. The lag component is significant, whereas the error is insignificant. You are getting income to be significant at 5% level and a negative relation between income and crime rate in your locality. Instrumented variables have been reported and relevant instruments, those instruments have been reported. W underscore INC, W underscore open, neighboring areas income, open space related to house. These things are not related to error of the concerned locality. So these have been considered for the space related variable, space related factor. However, simple open variable has been considered as an instrument with respect to x. That's the idea. Is it all right? 3 models everybody could estimate, and understanding what are the things you are getting in your analysis. So, for these cases, you are not getting Anselin's pathway. You need to run the model and finally decide which one is the best one. So, in this particular case, with the lag model, we are getting the ultimate result. Your result is not changing at all if you run SARMA. So, you will stick to your lag model. Running 3 models, error is insignificant under all the circumstances, both in case of error model as well as in case of SARMA. So, you have to stick to the spatial lag model. So, this particular case is related to the spatial lag component. Crime in my locality is a function of crime in neighboring locality. So, this is the aspect which is important. Not the error, rather y variable itself has the spatial component present here. Any question? Any question? Look, if you try to estimate using ML, not possible. Using this geoda space, and also naturally these options will be not available using ML. We have to stick to the least square based technique for this, for handling the endogeneity with respect to x variables. So standard is applicable, lag is applicable, spatial error is applicable. This is applicable in terms of GMM, and we will be not able to estimate basically the ML models in this case. Theoretically, we can, we using some other softwares we will be able to do, but we'll be not able to handle endogeneity with respect to x if we use geoda space. Okay, so a number of aspects related to regression has already been covered. The 2 more things in terms of regression will be covered in the due course. One is, if along with lag in terms of y variable, we like to incorporate lag in terms of x variables as well. Here we are considering crime rate in my locality is a function of crime rate of neighboring localities. However, we are not considering, the household valuation in my locality is a function of household valuation in neighboring locality. That kind of thing we are not considering here. So if we consider the housing value in my locality, that is also a function of neighboring locality. The income, the individual's household income, the households are getting in my locality is functionally related to household income in my neighboring locality. If that kind of lagged elements we want to incorporate in the model is becoming complicated, as you are understanding so many lags in terms of space for the y variable as well as for the x variables. That can be done using a totally new format, which we call the Darwin model. So, in the next class, we will cover this kind of Darwin model, and we will also start talking about GWR, geographically weighted regression model. So, we will consider local areas and we'll try to build up models based on the local areas. So you will get some ideas about that. We will be not able to do everything because of the limitation of the software. If you want to learn everything, you need to use more, softwares like R, etc., stronger softwares. You need to use stronger softwares. Okay, so this is all for today. If anybody has any question, please ask me. Please complete your assignment by the weekend, and I'll send you one more assignment which is related to endogeneity. Okay, so already one assignment is there, and I'll add assignment related to endogeneity. Yes, Kolnulini?
I couldn't give my attendance
Okay, okay,
2 minutes. Sorry, ma'am.
okay, okay, I'll give. Okay, so since a lot of things are already covered, okay. Now, if you start giving the feedback regarding whether you did not understand anything, or you want that this particular part will be covered, or some of the points related to this particular thing will be discussed, that will be very good for us. That will be very good for us. Okay, and you have to finish your assignments in the due periods, because this is a certificate based course, and if you cannot complete your assignments, etc., it will become a little bit difficult for us to provide the certificates. Okay, so please complete the assignments. The previous one also is not complete for everybody. This particular assignment you also need to complete, and some more assignments we are going to give you. So please complete the assignments. Okay, thank you very much. Your
Ma'am, shall we post it in the classroom or send by the mail?
everything is possible. If you post it in the classroom, that's fine. If you send it via mail to me, that is also fine.
Okay, ma'am. Ma'am, one more question, ma'am. From where means the database means the statistical data economic means this database is some examples or some probable database. Can you just suggest? From Geoda, we can download a few statistical data, but
And actually, the data NSS, NFHS, the data set where you have the lowest denomination like district, etc., or if it is household level data, and your household level map is also available, in that case you will be able to use those kind of secondary database. Since the map we are using, the lowest denomination is the district. Therefore, we are using district level information from NFHS data. At this moment, I'm using NFHS or DHS data, Demographic Health Survey data. Okay?
okay, ma'am. Thank you.
You can use a number of secondary database, and you need to check what is the corresponding map available for your analysis.
And then, ma'am, we can merge for other variables also if we can find such data. Yes, ma'am.
Definitely. Everything you have to take in terms of space. If district is the lowest denomination, you have to consider percentage of household facing these, etc. If household is lowest denomination, you can simply consider directly the household information. That's the thing.
Yes, ma'am. Thank you so much.
Anything else? Any other question? So please check everything. Okay, we are coming back on next Monday. Okay. Good night.
Good night, ma'am.
Good night, and thank you, ma'am.
Thank you, ma'am.